and welcome to Applied Mathematics for Business, CQMS 110. I am Dr. Pauline Fu. In this lecture, we'll talk about exponential and logarithm functions. Topics include exponential functions, logarithm functions, properties of logarithms, logarithms to the base 10. So first, exponential functions. Exponential functions are extensively used in real world. For example, the compound interest, population growth, radioactive decay, and other applications. So let's look at an example. When we did quadratic functions, we have, for example, gx equal to x squared. This is quadratic function. Okay. But when you have x in the power position, so fx equal to 2 raised to the power x, this is an exponential functions. Okay, so the first one, exponential functions. The second one is quadratic function. Okay. How do you distinguish between them? You look at the position of x. If x is in the base, that is the quadratic function or polynomial function. If x in the position of power, that is the exponential functions. So what is the definition of an exponential function? It is fx equal to base b raised to power x. We have requirement for b greater than 0, b not equal to 1. And b is called base. The domain of exponential functions is all real numbers. The range of exponential functions are all positive real numbers. Okay. So, for example, this is an xy coordinates. In exponential functions, x could be any value from negative number to positive number, but y also take positive number. Y also take positive number. Let's look at the graph of exponential functions. Okay. So if you want to graph fx equal to 2 raised to power x, you take some value for x because x could be any number on the number line. So you take some positive number, negative number, and 0. And then you figure out what is the y. This is y. And after that, you have the points. So this is x. When x equal to -4, y equal to 1/16, etc. Okay, so when x equal to -4, y equal to 1/16, roughly here. When x equal to -3, y equal to 1/8, roughly is here. So when x equal to 4, y equal to 16, 4, this is 16. So you make point on the xy coordinates, and then you connect those points, and that is the graph of y equal to 2 raised to power x. Okay. And you can also do this by using Excel. Okay, so this is, I'm going to go to the Excel to demonstrate. So So I'm going to open a new worksheet. So what we are going to do, we are going to construct an exponential graph. Okay, so you have x, you have y. So x is -4, -3, 0, and then 1, 2, 3, 4. And y equal to 2 raised to power. Okay, raised to power of x. You use cell reference, and then you copy down the formula. So those are your y, and then you create a chart. Select x, y, go to insert, we command the chart, and you get this graph. It is the same as we get by hand. Okay, so that is the graph of exponential functions. Some properties of exponential functions. Our graph contains the point 0, 1. So when x equal to 0, y equal to 1. This is because any number raised to power 0 equal to 1. All graphs are continuous curves with no holes or jumps. Okay, it is a very smooth the graph. X-axis is a horizontal asymptote. Asymptote means remember the graph we created is for y equal to 2 raised to power x, and we get something like this. Okay, and this point is 0, 1. So let's explain horizontal asymptote means if this direction x take a very, very big negative number, okay, and y this curve extend forever, but will never intersect with x. So x is the horizontal asymptote. And when b greater than 1, bx increase, xs increase. In this example, b equal to 2. Okay. If you have b equal to smaller than 1, bx decreases as x increases. For example, if you have graph like, if you have function y equal to 1 over 2, and then raised to power x, okay, and this graph will be like this. Okay, this is this graph. So when you increase x, y decrease. Okay. Other properties for exponential functions. If you have 2 raised to power x multiplied by 2 raised to power y, okay, you keep the base 2. You add the power component x plus y. Okay. And similarly, if you have 3 raised to power x divided by 3 raised to power y, you keep the base 3 and you do the subtraction for the power x minus y. Okay. And this is the x raised to power x, then raised to power y. It is the same as keep base, multiply those 2 hours as a new power. And this one, you distribute this power inside the x and inside the y. You get this one. Similarly to this one here. Okay. If you have a raised to power x equal to a raised to power y, This is true only if x equal to y. And if you have x not equal to 0, a raised to power x equal to b raised to power x, this is true only when a equal to b. Base e, exponential functions. The name of e is named in memory of Swiss mathematician. Okay, you can guess the name, Euler. Okay, so we use the e use his last name. One of the most useful values of the base of exponential function is the e. Most often, when we use exponential function, we use base 10. We also use base e. Base 10 is important because we are using our numeric numbering system is built on base 10. However, e is also widely used in science and other disciplines. So we just finished the exponential functions. Now let's go to logarithm functions. If y equal to b raised to power x, this is the exponential function because x in the power position. Okay. If this is true, and we can say x equal to log base b y, and b greater than 0, b not equal to 1. So for example, y equal to log base 3, 27. Why this is equal to 3? Because this part equal to, we keep the base 3, 27, we can write down 3 raised to power 3. Okay, there is a property. So if you have a log, base is b, and then b raised to power m, the result is m. This is one of the property. Okay, that's why it is 3. Next, let's evaluate this logarithm. Okay, so copy down the base 3. 1 over 27 is the same as 27 raised to power negative 1. And continue write down 27 is 3 raised to power 3, and 3 times negative 1 equal to negative 3. Again, based on this formula, we get this result is negative 3. Okay. How do we graph a logarithm function? For example, we want to graph y equal to log base 2x. So normally what we would do, you take some value for x, and then evaluate y, you get those y value. And then locate those pairs on the xy coordinates. Those are the pairs. And the result, you get this line here. Okay, you get this line here. As you can see from this graph, the domain is all positive numbers here. The range is a real number from negative infinity to positive infinity. And the same graph can also be produced by using Excel, but Excel only has 2 base. One is base 10, the other is base E. Now, the question is, base E, we actually have a short form, ln, means base E. This question is base 2. We do not have base 2 in Excel. So we need to use the formula. That formula is change base formula. Okay, so the formula said, if you have any base, for example, base m, then n, you can change it to base 10, n divided by base 10, m. Okay, this is change base formula. So for this question, it is the same as the objective. We want to use Excel. The Excel only have base 10 or base E. So let's use base 10 in Excel. So this one equal to log base 10 x divided by log base 10 2. Okay, so now we are going to go to Excel. Logarithm functions. Okay, see, this is this question. Graph y equal to log 2 base 2 x. So take some value for x. I just directly type in those numbers, okay? And calculate for y. So use change base formula. Y equal to log 10, because Excel has log 10. Log 10, then x divided by log 2. Okay. And then copy down the formula. And after that, select X and Y, go to Insert, recommended chart. See, you have this graph, the same as we did by hand. Okay, just move over here. This is the logarithm function in Excel. Okay. Inverse function. So far, we did exponential function y equal to 2 raised to power x, and this is the graph. And we also did log function y equal to log base 2x, and this is the graph. The interesting thing is, if you draw a straight line y equal to x, these two graphs are symmetry above y equal to x. They mirror each other, okay? You see, they mirror to each other. We call those two functions are inverse functions. So the inverse function of y equal to 2x is y equal to log base 2x. The inverse function of y equal to log 2x is y equal to 2 raised to power x. Okay. And normally, how do you solve for inverse function? You do this. You start solve. If the question asks you, what is the inverse function of y equal to 2x? You solve for x. Okay. Based on the definition of log, x equal to base y, base 2y. Okay. From here, you solve for x. And normally, we would use x is independent variable, y is dependent variable. So from here, you switch the letter x and y, you get y equal to log base 2x. And this is the inverse function, okay? properties of logarithm. Okay, if you have a log base b, x multiplied by x, y, and you have an addition form. Okay, if you have x divided by y, take log, it is subtraction form. And this is exponential, this power n can be removed in front of log b here. And other property include 1, the log 1 equal to 0. If the base equal to this, the same number, it is equal to 1. Okay. And for this one, it is actually special case of this one. So you just move the power x in front of the log. Okay, and then use this one here. Okay. So this one, it is b raised to power log bx. The result is x. Okay. It looks like this b log b cancelled out. Okay. So let's do some examples. Write each of the following expression as the logarithm of a single quantity. Okay. So log plus log equal to, they have the same base, keep the base, multiply the numbers here. Okay. And log minus log, keep the base, do the division of these two numbers. Log plus log, first you move these two to here, okay, to the power of x. And then you use log plus log equal to this multiplied by this. And this one, so first you move this 2 into here, x raised to power 2. And then this plus means multiplication. So 3 multiplied by x squared. Minus means divide by this y. So you need to do more practice from the textbook questions. We already talked about the logarithm base 10. If the log is base 10, it is called common logarithms. Okay. The calculator just use log, represent base 10. Now let's do the calculations. How do you calculate log 426? Of course, you can do it on your calculator, but I want to show you how to do it in Excel. Move over here, and maybe room here. So log base 10, then 428, 420 or 26. Okay, remember any formula in Excel start with equal sign. So this is the number, the same as we get here. Okay. How do you verify you are correct? You need to do the exponential function. So 10 raised to power of this number must be what? 426. Okay. So we finished A. Let's do B. Log 2. What is log 2 equal to? Okay. So equal to log base 10, then 2 equal to 0.301. How do you verify? You use exponential equal to 10 raised to power 0.301. And the result should be 2. Okay. Last question, C. Okay. Log 0.03654. Oh, I missed 10, log 10. So you get negative 1.437. How do we verify? 10 raised to power, this number must be equal to 0.03654. Okay, this one here. All right, so this is the base 10. Okay. In summary, what we did in this lecture, actually just 2 topics. 1, exponential function. 2, logarithm function, as well as their properties and basic operations. Okay, that's all for today's lecture. Thanks for watching.